Well,
Yeah, I
that's
said
what
like maybe 2 hours.
I mean,
Yeah, no.
closer to now than battleground, but our area code is,
Yeah,
or
I tried.
our address is still labeled as
Depending on
battleground.
It's 15
minutes.
Okay. We are getting ready to start.
I live on no more
So,
talking about where we live.
section 2.1 is what we're looking at today, and 2.2. We're going to, excuse me, when you come in, if I'm talking, please don't disrupt. Okay, not polite. Okay, so today we're doing 2.1 and 2.2. So get out those notes. You should have them out when you came into class. We're taking in-class notes now, so you can write this down along with it. I try to cover a little bit of different things than what's in the book. Okay, so section 2.1 is what we're looking at right now. This is titled the distributive property. This is one name I'd like you to know. Distributive property. It's probably the only property that I ask you to know the word for it because we use it a lot. We have to use the distributive property, and there's no real other way of distinguishing what that is. I don't ask you to memorize commutative or transitive or associative properties. Those are also properties. I don't ask you to memorize those, but distributive is the one I do want you to know the name of, okay? It calls it removing parentheses. I like to give you the second half of the distributive property. It is multiplication over addition. And this part's important because we need to realize you have to have addition, which includes subtraction, inside the parentheses, and we're multiplying something over that addition and multiplication sign. Okay, so the basic look at a distributive property is something like this: 3 times x plus 2. Okay. Our order of operations says we should do inside the parentheses first. What's the problem here right now? Why can't I do inside the parentheses first? Yes?
Because we don't know the value of x.
Yeah, we don't know what the value of x is, so we cannot add x with 2 because we don't know what x is right now. Okay? So if you can't do inside the parentheses, then we use this distributive property. You don't need to use it otherwise, okay? If you can do what's inside here, there's no reason to use the distributive property, okay? So in this case, distributive property is this. It's basically you're multiplying the 3 by both terms, okay? I use it by indicating arrows. I'm multiplying 3 by the x, and I'm multiplying 3 by the 2. See the multiplication? It's going over the addition. So we're multiplying this, and then we're multiplying it here, so that 3 is being multiplied over the addition sign, okay? That removes the parenthesis, because now we've taken and we've done that multiplication. So in this case, parentheses cannot be done first, because we can't add those. So we use the distributive property to remove the parentheses. So this is a way of removing the parentheses without doing the operations in between. So we have 3 times x plus 3 times 2. I'm writing this out just so you see what's occurring. I've multiplied the 3 by x, and I multiplied the 3 by the 2, okay? You don't have to show this step, but at the beginning, if you need to, go ahead and show that. That's fine, okay? That's equal to 3x, because I can't do any more to that. Okay, I don't have to put the times sign in between. It's implied. When you put a number next to a variable, that's an implied multiplication sign, okay? Plus, I can do this work, 6, okay? So now notice there is no parenthesis there. We have two distinct terms. One is an x term, one is a constant term because 6 doesn't ever change. It's called the constant term. Okay, this one changes depending on what variable or what number x stands for. Okay, so if it's a 1, that would be 3. If it's a 5, that would be 15. So this number changes depending on, that's why it's called the variable term of x. Okay, and so it's just an x term. So that's really what the distributive property is. Now it works if you have this. Okay, it can work over more terms. We don't just have to have 2 terms. It can go through multiple terms. This term is different because it's got a P. This is different because it's got a Q. This is different because it's got an R variable. So if they have different variables, they're different. We can't put them together. I can't add 2P plus Q because I don't know what P is and I don't know what Q is. I can't add those. Okay. So what we're going to do is we're going to distribute, and I still like to do this. I like to draw it out for myself, okay, like that, and I like to show the multiplication. Okay, I'm going to take 1/4 times 2p. I'm going to take 1/4 times q, and I'm going to take 1/4 times negative r, or subtract 1/4 r. When you're doing this, the plus and minus signs just come along. There's no use changing them, but if you have a negative out front, we'll talk about that. I'll show that one in just a minute. Okay, so this is 1/4 times 2, and if you need to, if fractions are not your quickest thing, this is times 2p. The 2p would be up above, and there would actually be a 1 underneath that, because anytime I'm changing a number or variable into a fraction, we just divide it by 1. That's what we do. Okay, plus 1/4 q. I don't really need to write the q over 1. When I multiply by 1/4 q, it's 1/4 q. Then we're going to minus 1/4 r. Okay, we can put the little signs in there. If you like the dots for multiplication, include them. It's not wrong to include them. But usually if you see a number next to a letter, that's an implied. Mathematicians are terribly lazy. We like to drop as many signs as we can. Okay, and so we just drop that little sign because it's kind of ridiculous to write a dot in between it. It just means multiplication anyway. Okay. So then I go to do this work. This is going to be 1/2 because I can reduce that. So this is 1/2 p plus 1/4 q minus 1/4 r. So if you're multiplying by a fraction, it doesn't change. Okay. You can do division also. Division is just multiplying by a fraction. And remember, multiplication and division are related. When we divide, we're dividing by the reciprocal. Well, if it's a division by a whole number, you're dividing or multiplying by 1 over that whole number. Okay, so if I have this, I'll do 3x minus 6, and I'm dividing that whole thing by 3. Okay, we're dividing by 3. This is another way of writing distributive property. This really is 3x divided by 3 and negative 6 divided by 3. This can be rewritten as 3x over 3 minus 6 over 3 because we can't do anything here. But we can distribute that division because it's very similar to multiplication. It's really the same as multiplication. So I can actually distribute that 3 to both parts. 3 divided by 3 is 1, so this is 1x or x. 6 divided by 3 is 2, so my answer would be simplified down to x minus 2. Okay, that's using the distributive property. So that's really what we're looking at when we're working with these. Okay, so that's how we remove them. We are going to talk about in a minute how to use this to do mental math. It's really fun to learn how to do mental math that you can do quickly. Okay, mental math is always a good thing to learn. Do you know why?
Because it helps us mentally.
Okay, that'll give you. What else?
Well, I'm not mental anymore.
No, technically you're becoming more mental.
Yeah,
Well,
you're
that's the
actually.
point.
So why do we? Yeah,
You can do problems in your head.
you can do problems in your head. Do we ever need to do problems in our head? Just think about walking around.
Yeah, when you're walking around or doing measurements,
Sure.
if you want to fly a plane, you have to do quick measurements.
Okay, you
wind
do
speed
quick
and all that.
measurements and you have to add them quickly.
Yeah.
Okay, so you need to learn how to use your measurements in your head. When other times might you do that?
Estimating max height.
We don't need to talk about that.
Okay, let's think.
Estimating
Okay,
price.
I do want you guys to not do so much like condemning
Estimating
each other
price,
by
yeah.
doing
you're
those
not filling up my
things.
bucket,
Okay, yeah. Let's work on filling somebody up instead of trying to knock them down. And so be serious when we're doing examples,
Oh, I
okay?
remember in like second grade when we had that filling up buckets thing.
That's what downstairs, my sister, that's what they've been working on.
On filling
recently.
out buckets, yeah.
So
It's a
she's
good
like-
idea.
She's like, you should try and fill up my bucket more.
I've never heard of that.
You have never. You want to fill someone's bucket up, which means like make them happy instead of like
Positive
like
things.
positive with positive things.
When you give them a slam or something that's not nice, it really subtracts from their bucket. It makes them, yeah.
Even though if it's like directed nicely or like
Yeah, even if it's said in a joking manner, it can still be hurtful or take out people's positive thinking for the day. Now, my husband and I, we joke a lot, but we also reaffirm a lot so that we equal it out or go above on the reaffirming. We just like to joke, and so then it's just one of those things. Okay, Grayson. Yeah, let's not be young
continuing what I
kids.
was gonna say.
Yes.
Estimating price, not
Yes.
height.
Yes, if you go into a store, you should be able to estimate how much you're spending so that you don't get up to the checkout and say, oh gosh, that's too much money. I don't have that much money and now I'm going to feel embarrassed because I can't pay for it and I'm going to have to send something back. No, you should be able to estimate. Yes.
My dad does landscaping, so he has to like estimate how much like yards of soil or like how much it's gonna cost him.
Exactly. Your dad does a good job. He did my house. But yes, he does. And he has to estimate. He estimated how many of those, whatever they're called, cement blocks that he needed to fix my yard so I had a nice flat yard and not a sloped yard. And so, yeah, estimating costs or prices for a business is great, okay? I use it all the time, not just because I teach math, okay? That's not why. I use it all the time because my husband and I and some of our friends love to play games. We are calculating things all the time. We play dice and certain values are worth certain amounts and you have to add them up really quickly. So you're doing mental math and then you keep track of your score. Again, you're doing mental math most of the
You don't want to
time
have
when
a
you're doing math.
piece of paper on the side having you have to do the
Every little
every
calculation, yes.
long division, whatever.
Yeah, you don't want that. We also play what's called crowns, 5 crowns. That has a ton of and we've learned different ways where we're subtracting threes, we're adding different points. We have to triple things, double things, all that kind of stuff.
I think they're doing some sort of event.
It's a senior event, so let them do it. It's fine, just ignore it.
Why aren't you?
I was about to.
Yeah, let's not make a derogatory comment because seniors should be respected, people that are older.
There are buckets.
Yeah.
No, they're older. Yeah, exactly.
Yes. Okay, so that's basically section 2.1. We're just looking at what the distributive property does, We are using it to remove parentheses when we cannot do the operation inside the parentheses, okay? Let's go to 2-2. 2-2 is not a whole lot different.
Oh, not a lot of notes.
No, there wasn't a lot for that. So section 2.2, we're still using the distributive property. Okay, it's using the distributive property and then adding like terms. So here's where we're talking about what a like term is. So this is the distributive property. Again, this is one that I want you to recognize and be able to claim that it's a distributive property that we're using. Okay, so you need to know that name of this action. Okay, we are also looking at like terms. Okay, so we have to look a little bit at what a like term is. Okay, can somebody tell me how they would describe a like term? How would you know if two terms are alike? Yes, Grayson.
If they're the same letters.
Okay, yes. Like terms have to have the same letter or letters. So if I have 3x and 7x, those are alike because they have the same variable to the same exponent. Okay, an x squared would be different because that's really x times x. And so that would be different. So we have to have, it can have different coefficients. These are called the coefficients. The number in front, they're called coefficients. Okay, this is called your variable. And if there's no exponent, the exponent would be the little tiny thing. So if I had, let's do 9x squared, that's your exponent, okay? Here it's an assumed one. Remember I told you we don't like to write. So mathematicians don't write the little one down there, but it really is there. That's what it is. It's a 1 right there. But we don't write it down because, that's the most common one is x to the first power. That's how we use it the most. So we just figure, okay, you see an x, you know it's just to the first power, okay? We start when we get to x squared, which means x times x, okay? So that's, in a like term, they have to have the same variable to the same exponent. So a like term has the same variable or sometime variables to the same exponent or exponents. Okay, so an example would be if you had 2x squared y to the third, a like term has to have both x squared and y to the third in it. It has to have that. So if I had 5x squared y to the third, these are like, those are like, they're like between. But if I had 2x squared y to the third and 5x y to the third, these are not alike. Whoops, I can't spell. That's an I, alike. Okay? Why are they not alike? What makes them not alike? Mad, what makes them not alike here? Between these two, what makes them not alike?
It's not x squared.
Yeah, this would have to be squared. So they have to have the same exact variables and the same exact exponents on those variables. Otherwise, they're not like terms, okay? If you have no variable, anything with no variable is alike. They are constant numbers. They are like any numbers we have worked with since we were in kindergarten. Okay, since we started adding, so don't make them more difficult. If there's no variable on it, they are what you've done work with forever. So don't make them more complicated because we're in algebra. Okay. Okay. So in this, the distributive property, it can be used like a couple times, and then you put this is where it's used most. They might give you all sorts of other examples, but I'm gonna show you this. Let's do 3x plus 5 minus 4x minus 2. Okay, notice there are two sets of parentheses. So our first thing would be to do inside parentheses, but we can't. So we have to use the distributive property. Okay, so here I have this 3 multiplied by these 2. So I'm going to distribute the 3 to both of those things. That's my distributive property. Distributing the 3 to the x, distributing the 3 to the 5. Okay, now this is kind of interesting. That's a minus sign. If you think about it, subtracting something is the same as adding a negative. So when we start working in algebra, this minus sign can represent a negative number as well as a minus subtraction sign. So we really start looking at the sign in front of them to see if they're negative or positive. This one's sign was nothing, which is assumed to be positive. Okay, so that was a positive 3 that we were multiplying. But this sign is -4, so we use it as a -4. So we're going to multiply the -4 times 2 and the -4 times -2, because now we're using the sign in front to tell us if they're positive or negative. Okay, so we do this one. 3 times x is 3x. 3 times positive 5, positive 3 times positive 5 is positive 15. We just distributed that one. Okay. -4 times x. Mason, what am I going to get if I do -4 times x?
-4x.
That's right. We just get -4x because there's no negative here, so they don't cancel each other. Okay. You'd have to have a negative there, and then it would become positive. Okay, so if I have -4 times -2, because we have to take that sign, okay, so this is really -4 times -2, Max, what do I get?
-4 times positive 8.
Positive 8, because a negative times a negative is positive when I multiply, so it would be +8. So that's the tricky one. We have to start learning that the sign in front is really whether it's positive or negative. A plus sign means it's positive, a negative sign means it's negative. Why? Because of this definition. Subtraction is defined as adding the opposite. So if I say 5 minus 3, okay, we can redefine that as 5 plus the opposite of 3, which is -3. Look at what that means. It's the same thing. So I don't want to write out this. I don't want to write this out. I just want to do 5 minus 3. So really, this is saying we're subtracting 3, which is adding a -3. We're going in the left direction 3. Okay, we're going down on the number scale. That's what this actually is. It's going down on the number scale. Okay, we're taking 3 away. Yeah, we look at it all different ways, but that's really what we're doing. Okay, so since this is true, since that's true, then this is -4 and this is -2. So I'm just trying to make sure in algebra, as we go farther, we drop the positive negatives and we really look just at the signs, subtraction or addition, and use those as what they are. Okay, so that's a new kind of concept, new way of thinking, but that's what happens in essence. I don't like it because they start just assuming you realize that, and people don't always just realize that. I need to point it out to you. That's what's happening. Okay, so now if we look at this, we want to put together like terms. Okay, so Matthew, what are 2 terms that are alike?
In that,
Yeah, in that expression right here. What two terms are alike?
4x and 3x.
Yeah. What kind of 4x is it?
It's
So-
negative 4x.
It's a negative 4x, because see the subtraction sign here? It actually means that's negative 4x. What is the 3? Is it positive or negative? It's positive because there's nothing in front of it. You'd have to put a negative. It's assumed to be positive. Again, one of those laziness things that math teachers, mathematicians don't like to put down. We don't want to put a plus because we just assume it's positive unless I indicate that it's negative. Okay, so mathematicians are very lazy in a lot of times. We assume a lot of things. And if you don't realize what we're assuming, you have a hard time reading it. Okay, and so I always say mathematicians are lazy. Just remember that. Okay, we don't write plus signs down unless we have to. The only time we have to is when they're in between terms. We don't have to write a plus sign out in front of a term. Okay, but we do have to write a negative out in front of a term. Okay, so this is 3x minus 4x, or 3x plus a negative 4x. What is 3x plus negative 4 or 3x minus 4? X? Yes, Grayson.
Negative x.
Negative x, negative 1. Now, if you're not familiar with working with, and I'm going to show you this because it helps, here's 0. 1, 2, 3. Here's 1. So this is negative 1. 1, 2, 3. So if I start at 3, okay, the negative sign says go to the left. That's what subtraction really is. Go to the left on the number line. This is go to the left 4 spots. So if I go 1, 2, 3, 4 spots to the left, because it's a minus, I end up at negative 1. That's how we know that 3 minus 4 is negative 1, or 3 plus a negative 4 is negative 1. Okay, so these are also direction signs. Positive goes this direction, negative goes that direction. So that's another way of looking at it. So when you're looking at that, visualize a number line. I'm starting at 3. I have to go 4 to the left. Well, I only can go 3 and I get to 0, so then I have to go 1 more, so it's negative 1. Okay, does that kind of make sense? Instead of memorizing, oh, this is what you do, just kind of visualize in your mind what's happening here. The subtraction's going to the left, so that'll help you figure out what your answer is. My daughter drew that many times. Like she would draw it out by 5s if it was a bigger number. She would draw the number line and just get used to that, so then she always pictured it. So she drew it up on her paper so she could always refer to it. And then as she did that more and more, that became imprinted in her mind so she could do the adding and subtracting really fast. Okay, so that's a hint of how you can do things. So this is negative 1x, which also can be written as negative x, because again, mathematicians are lazy. They don't write 1s. We don't write the 1 multiplied by the x. That's just how we do it. Okay, so that's combining those like terms. Okay, med. There's 2 other terms that can be combined. What are they?
15 and 8.
And what is that? Are they positive or negative?
Positive.
They're both positive, so what's our answer when we do that? Yes. So I will take either of these answers. I don't care. Either of these is acceptable. Okay? If you want to write the 1 in there because it makes you feel better, I am totally for it. Sometimes I write the 1 in because it makes me realize what's going on. If you don't want to write the 1 in there, it's not wrong, but I don't require you to write one of these differently than the other. And I have to tell you something, this is funny. I'm tutoring a girl right now in algebra, okay? She goes to Battleground School District, so I'm tutoring her. She's an artistic person. So when she draws her things, I can't do it because I'm not real artistic, but I'm just going to tell you something how she does it. She goes loopity, and then here she goes loopity to that, okay? Does that bother me? Absolutely not. But it bothers her teacher. Her teacher says you can't do that. And I'm telling her, go back to your teacher and say, yes, you can. It means the same thing. It doesn't matter how you get there. You can do 10 loops to get there. It means the same thing. And if that so what I'm trying to tell you is, I'm not going to, if you want to be artistic with this, be a little artistic. Okay? I'm not going to tell you not to, because that's kind of the fun.
As
Like
long
for
as
her,
it means the same thing,
yes,
you can do
as
it.
long as it means the same thing. And a little loop there getting to the 5 does not change anything. It's just a little loop. And for her, that's fun. So it makes math a little bit more fun for her to do. And so, just sometimes we get really picky on stuff. So if I start acting picky, tell me. And I might give you a reason why I'm picky on it. But if you want to draw loop-de-loops or you want to go underneath or whatever you want to do, as long as you get the same result, I don't care how you draw it. Okay, yes.
Also, as long as you don't cross lines.
Yes, you don't really want to cross the lines. I would say that, and she does not. I mean, she knows what she's doing. I've watched her a million times do it, but her teacher says you can't do it like that. And I'm going, are we focusing on the important parts of math, or are we focusing on how you like to draw something?
Like, you have to write the answers on the line.
Oh gosh, it's like, ah! Did you have a statement?
A statement? What?
Or
No, I have
question.
a question. What if I draw a circle around the math, all my math, and it gets in the problem with my math?
Okay, so if you're getting too exotic and it's too hard to read or follow, I'm not going to take it.
I also have another question. If mathematicians are so lazy, can you give us lazier work?
No, because we actually
Okay.
work hard on the things we do. We're lazy in what we write.
Mason, if you're still complaining about the workload we have, just look back at last year. Like,
Yeah.
Think about how much work we had last year.
Yeah.
Like this is
Yeah.
so easy compared to last year.
So be
Be grateful.
Be grateful. I can assign, if I find that you're not appreciating it, I can always assign you more.
No, I would.
Okay, I thought that might change the idea.
Except there would be like 5 odd even questions, but then like 10 or 15 odd questions.
Which your parents can still give you.
Which they can, but like
Yeah, Max is not doing the work.
Yeah.
Yeah.
I think he's
my
cheating.
mom gives me like 3 odd questions, and then if I get them all right, then she
Yeah.
isn't gonna give me more.
That's what
But
I
if
tell her to do.
Yeah, if I get them wrong, then she gives me more. But so far, I already know all this stuff.
So
So
far
it's
I've
like,
gotten 7, that was just because she didn't know necessarily which ones to assign.
I get 6. She picks 3 and I pick 3.
There you go. I like how you do this. This is fun. It's all different.
Yeah, I try to.
Yeah. Okay, so we're going to go a little bit more in 2.2. We're just going to talk a little bit about undoing the distributive, like doing the opposite of the distributive property, undoing what was already done. So this is called factoring. Okay, and it's basically finding what was distributed to both terms. So you're going backwards. So instead of saying 3 times x plus 5, what I'm going to go is 3x plus 15, and I'm going to ask you x plus, well, what did I pull out and what did I multiply it by? Now we can see it. So I'm going to give you this, and you're going to come up with this. So it's basically doing the reverse of the distributive property. Okay. Now, if we multiplied to get to here this way, we're going to do the opposite to go back here. We're going to figure out what divides into both of these numbers and get that answer. So if I look at this 3 and 15, what's a number that divides into both 3 and 15? Yes.
3?
Yeah, 3. Okay. So if I divide this by 3, the 3 is what comes out because it's what was multiplied through. 3 divided by 3 is x. 15 divided by 3, positive 15 divided by positive 3 is 5. Notice I got the answer, so we went this way, but what factoring is going backwards from the distributed answer. Okay, so let's try one that's different. 8x minus 24. Okay, so I'm giving you 8x minus 24. I want to know what did we multiply and what was inside the parentheses in here. Okay, that's what I'm looking to fill out. Okay, what number goes both into 8 and 24? Yes?
4.
4 does. There's actually a higher number. What's the higher number? 8. Okay, 8 goes into both 8 and 24. This is where your multiplications tables come in handy. You need to know those real quickly. So I can divide this by 8 and this by 8. So what I'm dividing by comes out in front. What goes in here is the actual division. 8 divided by 8 is 1. So this is going to be 1x.
Which is just x.
Which is just x. This is a negative. We can just pull the negative down because we're always dividing right now by a positive number. Okay, so negative 24 divided by 8
is 3.
4.
is 3. Okay, that's okay. Negative 3. I confuse those two. 4 times 6, 3 times 8 get you to 24. That's why we tend to say one of those. Okay, so that is negative 3. So what I started with was this problem of distributing, and I got this answer. So now we are given the answer, and we are looking for the problem given distribution. We're going backwards. So instead of multiplying it through, we're dividing it out. That's what we're really doing. So the opposite of multiplying something through is dividing it out. And so that's why what you're doing when you're factoring, you're dividing out what's in common. You're dividing out what's in common. Okay, because that's what was distributed to both terms, the same number, so you have to divide out what same number goes into both of those. Okay, so that's part of it. So you'll see some of that in section 2.2. It's just kind of an introduction to this. We will talk a lot more about factoring later, but this is just kind of an introduction, really brief introduction to get you started doing it forwards and backwards. Okay. Most times you are going to do it forwards. You are going to use the distributive property. I'll just tell you that probably 90% of the time you're going to use it in this form where you distribute it through. There's a less amount of time, 10%, when you're going to divide it back out. Okay, so that's something just to know. Okay. Now what we're going to do is do a little mental math. How do I do mental math? Okay.
You guys are becoming mental.
No.
Didn't make them up.
Okay.
Going to a cycle word.
No. Mental math means you're doing it in your brain. Okay. It doesn't mean anything about any other things that go along with the word mental. Okay. Mental just means you're using your brain, or it's associated with your brain.
Or
That's
you're
all
making
it is.
images with your brain. Imprinting images with your brain.
That can be true.
Or if you're not very imaginative, you just use like motor power. I don't get it because I'm very visual.
Yeah, well, you can do this visually too.
Yeah.
You have to think about it. So I'm going to show you some ways to use multiplication or the distributive property to actually multiply things quicker. Okay, so there's all sorts of ways to do this. But let's say you have 97 times 52. Okay, so I'm going to show you how you can do this quicker. I'm going to